As we get ready for our test over our ratios and rates unit, I wanted to kind of give you an opportunity to kind of see how I work through some of these problems from our review. Feel free to jump ahead, skip to whichever problems you might need a little bit of extra help with, but just so you can kind of get a little extra help as you're working on your review and preparing for our test this week. So I'm going to start with number 1, and I'm going to kind of talk you through how I would think through a problem like this. So it says, which statement correctly describes the images of the clouds and suns? So you can see that I have 6 clouds over there and 4 suns. So what I'm going to do is, I know it looks like a multiple choice problem, but it says select all that apply. So it's not as easy as just finding one quick answer and moving on to the next one. What we really need to be doing is checking each one of these to see which one works. And a lot of times what I like to do is I like to start with what I can see in the problem. There are 6 clouds and 4 suns. And I know since I'm dealing with ratios, I always want to simplify that ratio. So 6 and 4 could each be divided by 2. So I get a ratio of 3 clouds to 2 suns. That's kind of my simplest form. So think of it as I could kind of put 3 clouds and group them with 2 suns and be able to divide everything up equally. Now I'm going to check it with each of those possible answers. So the first one says 3 clouds to 2 suns. Well, that's exactly what my ratio said, so I'm going to select that one. Then it says for 4 suns, there are 6 clouds. Well, that's right what I started with here. 4 suns to 6 clouds, so I can select that one. Then it says for every 2 clouds, there's 1 sun. Well, we said that for 3 clouds, there's 2 suns. So 2 clouds, 1 sun. Is that the same thing as 3 clouds and 2 suns? Well, to get from 1 to 2, I could multiply by 2. But could I do the same thing to get from 2 to 3? No. So these are not going to be equal to each other. So this one does not work. Then I look at my fourth one. For every 3 suns, there are 2 clouds. So 3 suns to 2 clouds. Well, let's take our information over here. We said we have 2 suns for 3 clouds. So they try to trick us on this one. They do have a 3 and a 2, but it's 3 suns instead of 3 clouds. And instead of 2 clouds, they have 2, or instead of 2 suns, they have 2 clouds. So because the terms weren't right, this one's not going to work either. So it matters which number those, or which kind of picture each of those numbers is representing. But we kind of work through each one of them, check it against the information we have to see which one works. Here's question 2. I'm going to use my highlighter here because while this looks like a multiple choice question, what this really is it's saying check each one of these to see if these work, because we're going to select any of them that are true statements. So I'm going to start with what's in the problem. It says for every 2 strawberries, there are 5 grapes. So I'm going to jot that off to the side. 2 strawberries to 5 grapes. In problems like this, it's often a good idea to also figure out your total number. So if I had 2 strawberries and 5 grapes, that would give me 7 total pieces of fruit. Okay. Now, using that starting information, I'm going to kind of work through each of these different ones and see which ones work. Basically, think of it kind of like in our ratio tables. We want the numbers to grow or change at the same rate for them to be equal to each other, for them to be equivalent. So the next one says 25 grapes to 10 strawberries. So I'm going to do 25 grapes, 10 strawberries. And then I'm going to go back to my starter information over here and pull the same information. So I need grapes, 5 grapes, and strawberries, 2 strawberries. Now I want to check to see, are those equivalent to each other? And we do that by checking to see how did they grow. Well, to go from a 5 to a 25, I would multiply by 5, I can do the same thing to my 2 to get to 10. So since I did the same thing, they are equal. So I want that one. So think of it as we're kind of checking each of them as we go. So the next one says 28 pieces of fruit to 20 grapes. So 28 fruit over 20 grapes. So I'm going to go back to my given information. I had 7 total pieces of fruit and 5 grapes. I'm just pulling for that information off to the side. And that's why I write it over there, so I have easy access to it as I do each part of the problem. Now I'm going to check for that same kind of pattern. How does a 7 turn into a 28? Well, I can multiply it times 4. I can do the same thing to 5 to get to 20. So I treated both parts of the ratio equally. It grew at the same rate. They each got multiplied by 4. So this one is equal, and I would say yes. Okay? Now I'm going to keep doing the same thing for each of these. So next one is 30 strawberries to 18 grapes. So 30 strawberries to 18 grapes. I'm going to check it against what I was given. So I was given 2 strawberries and 5 grapes. So now I look to see, did they both grow and change at the same rate? Well, to get from 2 to 30, I multiplied times 15. Can I do the same thing to 5 to get to 18? No. 5 times 15 is definitely not 18. So these are not equivalent to each other. So I don't want part C. All right, I'm going to erase a little bit of my work here, so I got some space, but this is why I spread it out on your page, so you had some room to do some scratch work. Next one, 50 grapes to 70 pieces of fruit. So 50 grapes to 70 pieces of fruit. So I go back and take that information from my given, 5 grapes and 7 fruit. So I'm using that chart off to the right. To get from 5 to 50, I multiply times 10. And do the same thing to my 7. To get to 70, so I want part D as well. So I'm just checking each of them as I go. Last one, 16 strawberries to 50 pieces of fruit. So 16 strawberries to 50 pieces of fruit. Notice how I'm just putting that letter next to them so I kind of remember which number goes with which type of object. Then I'm going to go back to my given information, 2 strawberries and 7 pieces of fruit. So 2 strawberries, 7 pieces of fruit. To get from 2 to 16, I would have multiplied times 8, but 7 times 8 is not going to give me 50. So this one is not equal. I didn't treat both of them equally. They didn't grow at the same rate, so I would not choose part E. Okay? So I'm just checking each one of those against that starting information. Question 3. This one's a little shorter. It says, in class, there are 8 students that wear glasses, 12 that do not. So I'm going to start by jotting down that information. 8 that do, 12 that don't. And then remember what we talked about last time? It never hurts to also know your total. It's good to have all that information waiting for you so you can go back to it anytime you need to. If there's 8 students with glasses and 12 without, that means I have a total of 20 students. So now I have all the pieces of information. Now I can just pull whatever I need. So in the problem, it says, what is the ratio of students in glasses to the entire class? All right, so I need students that do wear glasses to the total number of students. Well, I know that there's 8 that do and 20 total. So my ratio is 8 to 20. Remember, for a ratio, we will always want to simplify. So to simplify, we look for what can they both be divided by. 8 and 20 can both be divided by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. So I get a ratio of 2 to 5. All right, next one. It says a 5-pound bag of potatoes contains 15 potatoes and costs $3.90. So I got 3 pieces of information. But look at what it asks. What is the cost? So that's money per potato. Well, I had 15 potatoes. So in this case, it gave me lots of information. I needed to look at what the question asked for. It said cost and the number of potatoes, not the number of pounds. So in this case, I'm not going to use that 5 pounds. Well, cost came first, and we know money goes on top. Potatoes, well, that was 15 potatoes. We want to know the cost per potato. Remember that word per means 1. So we want to know our unit rate. What's the cost for 1 potato? Well, to find a unit rate, we always divide by that denominator. So I'm going to divide by 15. So in my calculator, I'm going to do 390 divided by 15, and I get 26 cents per potato. That's my answer. Oh, I shouldn't have had my E there on my potato. Sorry about that. All right. Next one. So this one's similar to the last one. It says, if the record number of hot dogs eaten is 75 hot dogs in 10 minutes, how many hot dogs are eaten per minute? Remember, per minute is code for 1 minute, meaning find your unit rate. So hot dogs was listed first, so 75 hot dogs over 10 minutes. I want to know how much for 1 minute. So to go from a 10 to a 1, I'm going to divide by 10, and I get 7.5 hot dogs in 1 minute. Okay, I found my unit rate. Then it said, at that rate, how many hot dogs did the champion eat in 4 minutes? Well, remember, once I know my unit rate, I can find any number of minutes after that. If it's 7.5 hot dogs in 1 minute, if I want to know how much for 4 minutes, I just multiply times 4. So 7.5 times 4 is 30 hot dogs in 4 minutes. So I set up the original information, divided by my denominator to make it into a unit rate, and then I just use that unit rate to find my new amount. All right, number 6. It says, how many calories are there in 5 dishes of chocolate pudding? So we want to know how many calories in 5. Here's what we're given. They just gave it to us in a picture instead of spelling it out. It shows us that there's 1,006 calories in 2 dishes of pudding. We want to know how much is in 5. So we're going to take the same strategy we did in the last problem. We're going to find out how much it is for just 1, because a 1 can very easily turn into a 5. So I'm going to divide by 2, because I want to divide by that denominator. And I'm going to find that it's 503 calories per dish, because I divided by 2. Now I'm going to use that unit rate to find out how much it is for 5 dishes. To do that, I'm simply going to multiply by 5. That's how I turn a 1 into a 5. 503 times 5 is 2,515 calories in 5 dishes. So my answer would be 2,515. Okay. All right, almost done. Number 7. This is one of our ratio tables. So it said a hippopotamus can eat 120 kilograms of food in 3 days. So if we keep at that same rate, how much would it be for a different number of days? Okay. If you remember from when we practiced these in class, we go from the information we know to the information we want to know. So I might start with this box. I want to know how much is in just 1 day. Well, I'm going to look up here. How did I get to that 1? Well, I know the 3. 3 to 1 was divided by 3. So I'm going to do the same thing to my other number. Remember, they have to grow and change at the same rate. 120 divided by 3 is 40. Now I'm going to look to grow to other rates. So now let's go to 8. A good rule of thumb is that first column often is going to be very useful in getting to your other numbers. Like a 1 can turn into an 8 simply by multiplying times 8. So I do the same thing to my 40. I treat them both equally, and I get 320. Okay. To get from a 1 to a 12, I would simply multiply by 12. So I'm going to do the same thing to my 40. They're both going to grow at the same rate, but those arrows help me focus on which numbers am I looking at and what number am I multiplying by, and I would get 480. Okay? I'm going to kind of clear out my work there just because it's getting crowded, and I'm going to do my last one. Now I want to go to 21. Again, go with one that you knew before. In this one, you could use the 1 or the 3. I like to kind of be consistent with my 1 here, as long as it's going to work. So you get from 1 to 21, I would multiply by 21. So I do the same thing with my other one. 21 times 40 is 840. So always look for what did I multiply or divide by to get to that number. I'm going to do the same thing to its matching piece, and I'm going to keep working my way through it. All right, last one. Okay? Again, this is a multiple choice question, but don't think of it as a quick circle one and then move on. You literally need to check each one of these to see which one works. So we're given some information. It says Gloria has a job at the mall wrapping gifts. After 30 minutes, she was wrapping 6 gifts. So that's her rate. So you'll notice 30 and 6 start each of our ratio tables. What we want to know is which ratio table got filled in correctly from there. So it's kind of like the last problem, but we're checking their work instead of having to fill in the numbers. So here's how I would work through this. To get from 6 to 12, I would multiply by 2. Did I do the same thing up top? Yep, I multiplied by 2 to get to 60. To get from 6 to 24, I would multiply times 4. Did I do the same thing to get to 90? No, I multiplied by 3. So it didn't grow at the same rate, so this can't be my ratio table for this information. Next one, 30 to 60 is times 2. 6 to 10, not times 2. Okay, so that one was an easy one to knock out. Here, 30 times 2 gets me 60. 6 times 12, or 6 times 2 gets me 12. That works. Then 30 times 3 is 90. 6 times 3 is 18. Then 30 times 4 is 120. 6 times 4 is 24. So that one definitely works. Let's double check the last one just to be on the safe side. To get from 30 to 60, I multiply times 2. Can I do the same thing to 6 to get to 8? Definitely not equal to times 2. So I eliminated that one. So I'm just checking each of those pairs in that table until I find which table has been correctly filled in. All right, I hope that helps. Feel free to go back to any of the problems that you still need to work on, and good luck.